So what we're looking at on this chart is a relationship between the accumulated carbon dioxide that is accumulated in the atmosphere because it stays there for a long time once we've put it there. The carbon dioxide that's accumulated in the atmosphere since the beginning of the Industrial Revolution, that's the horizontal line on the chart, versus the global mean temperature rise, so the global warming, which is the vertical axis. And the black crosses show the relationship between that accumulated carbon dioxide and the temperature for the past decades. And you can see they sit pretty much on a straight line. So as the carbon dioxide accumulates, so the global temperature warms roughly as a straight line. And there are theoretical reasons for thinking it's close to a straight line in this range. What this tells us is two things. Firstly, every additional ton of carbon dioxide that we lodge in the atmosphere is going to warm the climate. So if we want to stabilize the climate, we've got to stop emitting, or we've got to get to net zero of carbon dioxide emissions and stabilize the carbon dioxide concentration to stabilize the climate. The second thing that this plot shows in the gray cross is where we'd like to be, which is to keep climate below 1.5 degrees above pre-industrial. That's the Paris Agreement. And you can see there that we haven't got much more carbon left in the bank that we can put in the atmosphere if we're going to remain below that level. It's probably 20 to 30 years at current rate of emissions maximum. If we continue to emit as business as usual, our best estimate is that red curve with 2.5 degrees or so of warming by 2050. So this is where the choices begin, depending on whether we aggressively reduce emissions or whether we continue. If we could move on to my penultimate slide, please, before I pass to Emily. The chart on the left-hand side shows the emissions of carbon dioxide per year, and the black line is what we've observed up until about 2020. So an increase in the amount of carbon dioxide we're putting into the atmosphere each year. You'll remember that every ton of carbon dioxide we put into the atmosphere warms the climate. So if we want to stabilize at 1.5 degrees, it's the area for the scientists amongst you under that graph that matters, meaning the later that we leave the cut in emissions, the more rapidly we need to cut emissions. Hence the blue curves get steeper and steeper. So this is the scientific articulation that if we want to stay below 1.5 degrees, the longer we leave the reduction in emissions, the more rapidly we will need to do that. And this chart quantifies that statement, but it's reaching very urgent to keep 1.5 alive. The thermometer on the right-hand side says where we are now. So we're currently at 1.2 degrees of warming in 2021, latest figures from Met Office. We'd like to stay below 1.5 degrees. If we take all of the pledges from the 2030 targets and assume that they will happen, that will get us down to 2.4 degrees. So fantastic progress, but it needs to be achieved. If we take all of those 2030 targets and the net zero pledges and all the pledges made at Glasgow, that will see us to something like 1.8 degrees. So it's above 1.5 degrees, but we are on the right trajectory if we can achieve the commitments that have been made to date. Still a long way to go, and implementing those, as Emily will speak to, requires huge action. And if we could move to the final slide, please. So the final slide is a reminder, as Patrick introduced, that if we look back even over the last 2 years around the world, the number of climate extremes that we're seeing have been really quite sobering, ranging from the European flooding, the North American heat wave from last year, and this year India and Pakistan have experienced temperatures exceeding 50 degrees centigrade. What all these events have in common is that we're able to estimate how much more likely these events are because of climate change, and they are more likely. The degree of more increased likelihood depends on the event. North American heat wave is virtually impossible without climate change.